finish our discussion about ellipses. Last class we learned how to graph them and analyze them. Today we're going to learn about how to write the equations and also find the eccentricity of ellipses. So to start, we're going to start with writing an equation for an ellipse with different characteristics. So this first one says that we have a major axis that goes from negative 6, 2 to negative 6, 8. And we have a minor axis from negative 3, 3 to negative 9, negative 3. Now what we need to notice is that the major axes, the x's don't change but the y's do. So because the x's don't change but the y's do, this basically lets us know that our major axis is going to be vertical and our minor axis is going to be horizontal. Because again, the y's are the ones that change for our major axis and our x's are the ones that change for our minor axis. So if you remember, to write an equation for an ellipse in standard form, it's going to be x minus h squared over a squared, or actually not a squared, it's actually going to be b squared here because just like I said, the major axis is going to be vertical. So that means our bigger value needs to be underneath our y's, okay? And so remember, a and b represent basically represent how far the vertices are from our center along our major axis and our minor axis, the A and B are. Okay, so the truth of the matter is we need to figure out the length of our major and our minor axes, because once we figure that out, we just divide it by 2 and then we find our values for A and B. So to go about finding the length of our major axis, we're basically going to figure out, okay, well, how far is negative 6, 2 from negative 6, 8? And so we basically figure out, okay, well, from 2 to negative 8, that's a total of 10. Now, if you're wondering, well, how do you do that? Well, all you do is do 2 minus a negative 8, old school distance, when you're looking at a point on a number line, and you get a length of 10. Okay, so 10 represents the length of your major axes. And so all you do is divide by 2 to get the value of A. You do the same thing with your minor axis. You do negative 3 minus a negative 9 to find out that that is 6. So the length of our minor axis is 6. So then we just divide that by 2 and we get 3, which is the value of B. Okay? So that means that when we go to plug it in, our A squared is going to be equal to 25 and our B squared is going to be equal to 9. And that's what goes underneath our x minus h and our y minus k. Now the last thing we need to find is our center. And so really and truly, the center is the midpoint between the vertices of our major axes or the midpoint between the co-vertices on our minor axes. So what we basically need to do is we need to find the midpoint from negative 6, 2 to negative 6, 8, or the midpoint from negative 3, 3 to negative 9, negative 3. Doesn't matter because we'll still get the same answer either way. So old school midpoint is x1 plus x2 all over 2, and then y1 plus y2 all over 2. Okay? Well, negative 6 minus 6 is a negative 12. Divide that by 2 is a negative 6. And 2 plus a negative 8 is a negative 6. Divide that by 2 and we get a negative 3. This is the center for our ellipse. So when we go to plug in our final answer, which I'm going to write right here in this pink box, is going to be x plus 6 squared all over b squared, which was 9, plus y minus a negative 3, so it turns into a plus, squared over 25 equals 1. And that is the equation for our ellipse with a major axis there and a minor axis there. Okay? Next, we're going to take a look at our next example, which is different. We have vertices at negative 4, 4 and 6, 4, and we have foci at negative 2, 4 and 4, 4. So remember, the vertices are located along your major, at the ends of your major axes. So we can figure out, okay, well, what's the length from vertex to vertex? Then we do the same thing that we did before. We take half and then we have our value for A. Okay? So in order to figure out the length from -4,4 to 6,4, we can do old school distance formula, or we can kind of use a little bit of knowledge and figure out, okay, well, from -4 to a +6, that is a total of 10 units. Okay? So the length here is equal to 10. Again, if you can't spot that out to see that that's from -4,4 to 6,4, it's 10 units. You can always do old school distance formula, and you'll get that. Here's the formula for old school distance if you want to use that instead. Okay? So if the length of our major axes is 10, then we just divide that by 2 to get a value of 5, and that equals A, which means that A squared is 25. Okay? Now, the foci are what's going to help us figure out the value of B. Okay? Now, remember, the distance from foci to foci is basically going to help us determine the value of C. Okay? So we're going to figure out how far the foci are from each other. So from -2,4 to a +2,4 is 6. And so to figure out the value of C, we're going to do a similar process. We're just going to divide by 2, and we get that C is 3. Okay? So to find the value of A, we just figure out what's the length from vertex to vertex, and then we divide by 2 to get the value of A. To find the value of B, we figure out the distance from co-vertex to co-vertex and divide that by 2. To find the value of C, we find the distance from foci to focus to focus, and then we divide that by 2. And then we use this information to help us figure out, okay, well, what's going to be B? Because you know that C squared equals A squared minus B squared, so we pretty much plug in. C squared is going to be 9. We already know A squared is 25, so we're going to basically set this up and find B squared. Subtract 25 from both sides to get a -16 equals a -B squared. Divide by -1, take the square root, and B equals 4. Okay? Well, actually, we need B squared to write our equation, so I probably shouldn't take the square root, but it's okay. All right? So now we have our A squared, we have our B squared. Now we just need our center. Okay? Well, from vertex to vertex, remember, the center is in the middle, so we need to figure out the midpoint between -4,4 and 6,4. So we do midpoint formula again, or you don't have to. If you can recognize where exactly the midpoint is, then that's fine. You can do that. So -4 plus 6 is a +2. 2 divided by 2 is 1. 4 plus 4 is 8. Divided by 2 is 4. So our center is located at 1,4. Now we have all of our information to write our equation. But is this a horizontal major axis or a vertical major axis? Well, considering that when you look at the vertices, which again are at the endpoints of our major axes, since our x's change and our y stay the same, that basically lets us know that it's going to be a horizontal major axis, which means that our A squared is going to go underneath our x's. So our equation, which I'm going to write in blue, is going to be x minus 1. So remember, our center is 1,4 over A squared, which is 25, plus y minus 4 squared over B squared, which is 16, equals 1. And that is the equation of our ellipse. Okay? So again, just to recap, look at what you're given. If they give you the vertices and you notice that the x's change and the y stay the same, that basically lets you know that it's going to be a horizontal major axis, which means your A squared needs to be underneath your x's. And then to find the value of A, you figure out the length from vertex to vertex, and then you divide by 2 to get the value of A. If you were given your co-vertices or the endpoints of your minor axes, then you figure out the length from co-vertex to co-vertex, and then divide that by 2, and that'll give you the value of B. If you ever need to figure out C to help you find A or B like we had to do in this problem, you figure out the length from focus to focus, and then you divide by 2 to figure out your value of C, okay? And remember, to find your center, you just need to find the midpoint between your vertices or your co-vertices. So I want you guys to take a moment. I know the next one is a little bit different because you're given your foci, but you're also given the length of your major axes. And so I want you guys to go ahead and try to figure out an equation using those 2 examples that we just did. And when you're ready to see the answer, press play, and let's see how well you did. So hopefully you realize that if they gave you the length of your major axes, that means that a squared is going to equal that number, and that number is that a 30? It is a 30, okay? All right, and considering that we do need a squared for our equation, we're going to leave that as a squared equals 30. Now, to figure out B, we need to take the fact that we're given the focus, or the foci, and we need to figure out the length and divide that by 2 to find C. C is going to help us find B. So from 19.3 to negative 7.3, well, wow, that's a really big distance. And so that's going to be, it's going to be 26. Okay? That's going to be 26. So, the foci length, you divide that by 2 and you get 13. Okay? So then that is the value of C. So then you use C squared equals A squared minus B squared to help you find B squared for your equation. So 13 squared is 169, A squared is 30, and then minus B squared. Sorry guys, I had a brain fart here. Okay, I knew something wasn't working out right. It was right here with my A squared. Okay? So let's fix this right now. So if the length of your major axis is 30, then I forgot that you have to divide by 2 to get the value of A, which is 15. When you square it, you get 225, which equals A squared. And that's what I should have plugged in here. Tell me answer this. Sorry, I hope that didn't throw anybody off. If you did it right the first time, good job. I know you're probably like, hold on, Ms. Anderson, this isn't right. So then you take 169, and then you subtract 225 to get a negative 56. So we have negative 56 equals a negative B squared. So then B squared equals a positive 56 that we need to use to plug into our equation. So A squared equals 225, B squared equals 56. We need to find the center. Well, if you recall, you know, the center is the midpoint between each vertex. And if you think about it, the foci are located along the major axes, and so they're actually equidistant from the center as well. So we can find the midpoint of our foci to find our center. So the midpoint, 19 plus a negative 7 over 2, 3 plus 3 over 2. That is going to be 12 over 2 and then 6 over 2. So our center is located at 6, 3. And because our foci is located along our major axes and our x's are changing, that basically lets us know that this is going to be a horizontal major axis, which means our A squared needs to go under our x's. So this is going to be x minus 6 squared all over A squared, which is 225, and then y minus 3 squared over B squared, which is 56, equals 1. All right, we got another one to try, so go ahead and pause this video and then try this next one. All right, so the length of our minor axis is 10, which means that we have to divide that by 2. And so we'll have 5 equals the distance from our center to a co-vertex. So then we need to square that to get 25. And since it's along our minor axis, we know that B squared equals 25. Now our vertices, which are located at the ends of our major axes, we need to figure out that length. Well, from negative 2, negative 4 to negative 2, positive 8, that is a length of 6. I mean, not 6. It's a length of 12. So we have to divide that by 2 to get 6. We square that to get 36, and that will be our a squared. So again, from negative 2, negative 4 to negative 2, 8, that's a length of 12 units. So we divide that by 2 to get 6. And so that's the distance from the center to one of your vertices. And then you square it to get the value of a squared. And since your vertices, the y's are changing instead of the x's, you know that this is a vertical major axis, which means the a squared is going to go underneath your y's. Now we just have to figure out the center. So we're going to find the midpoint between our vertices. And we're going to find our centers at negative 2, 2. Yeah, I did my math right there. So then our equation is going to be x plus 2 squared all over, again, since it's vertical, our b squared is going to go underneath our x's, and then our a squared is going to go underneath our y's, and it equals 1. Okay? If you're still having difficulty writing the equation from different given characteristics, it just takes practice. So you guys will get that practice when you're working on your homework. Now, the eccentricity of an ellipse is the ratio of c to a, like the actual value c to a. And this value will always be between 0 and 1 and will determine how circular or stretched the ellipse will be. So for any ellipse, it doesn't matter whether it's a horizontal major axis or a vertical major axis. The eccentricity is the formula E equals c over a. Now, the value of c represents the distance between one of the foci and the center. And so as the foci moves closer together, c and e both are going to approach 0. And when the eccentricity reaches 0, the ellipse is a circle, and both a and b are equal to the radius of the circle. So if you take a look, here's an example. All right, as you see, you have c and a, which is basically, remember, c is the distance from the center to one of the foci. And so the ratio between C and A is going to be actually really, really close to 1. So the closer that the eccentricity is to 1, the more of an oval shape it would be. And then the smaller that the eccentricity becomes, the more it's going to be a circle. Okay, so as you see, here's an example. The values are close together, so the eccentricity is going to be almost closer to 1. And then the smaller that C gets, the smaller the eccentricity gets. Okay, making it more of a circle the smaller that the eccentricity gets. So to determine the eccentricity is actually pretty simple. First off, you just have to determine what is a squared, what's b squared, to help you find your c squared, and then you use that to basically plug into the formula of c over a. Okay? So we look at this, we figure out that, okay, remember the bigger number is a squared, the smaller number is b squared. And so we use the formula of c squared equals a squared minus b squared to help us find c. Because remember, to find eccentricity is the formula c over a. So then c squared is found by basically taking 100, minusing it from 9 to get 91 equals c squared. And then we take the square root to get the square root of 91. Okay? Now I am going to use the exact value here to plug in because I don't want to continuously round throughout my answer. So it's going to be the square root of 91 over a. Okay? Now if 100 is equal to a squared, that means that a is 10. And now I'll type that into my calculator, rounding to 3 significant figures. And I have my calculator right here, nice and handy. So I'm going to type that in and find out that it's going to be 0.954, which basically lets me know this is going to be pretty stretched because it's closer to 1. All right? Not too challenging. So I want you guys to try this one, find my eccentricity. When you're ready to check your answer, press play. So hopefully you got this answer. Hopefully you found that c was the square root of 2, a was the square root of 19. And so when you divide them, you've got 0.32, which basically know that it's going to be more circular because it's closer to 0. All right, word problem here for you. It says the shape of an eye can be modeled by a prolate or a 3-dimensional ellipse. The eccentricity of the center cross-section for an eye with normal vision is about 0.28. if a normal eye is about 25 millimeters deep, what is the approximate height of the eye? Okay? And so if you really think about this, we're going to use eccentricity to find the value of C. Okay? Because we're told that eccentricity is, where is it? It's 0.28. So that means in our formula of C over A, E is going to be 0.28. Okay? Now we already know that if a normal eye is about 25 millimeters deep, that right there is basically going to tell us the value of A. Okay? So if it's 25 millimeters deep, then this is basically the length from vertex to vertex. So to find the value of A, we're going to actually divide this by 2 to get 12.5. So 12.5 represents the value of A, because it told us that's how deep it is. And so when we divide that by 2, that goes in for A. So then to find C, we're going to multiply the 2. And then when we do, I'm going to multiply it right now. I got my calculator nice and handy. We get 3.5. So the value of C is 3.5. Now the reason why we need to figure this out is because we're trying to figure out the approximate height of the eye. Now the height of the eye, if you think about it, okay, the height of the eye is basically the length of the minor axis, which means we got to figure out what B is and then double it. Okay? So we're going to use the formula of C squared equals A squared minus B squared, because that's the only formula that relates A, B, and C together. And then we plug in. So 3.5 squared equals 12.5 squared minus B squared. Okay? So when we type that in, see 3.5 squared, and then I'm going to subtract a 12.5 squared, I get a negative 144 equals a negative B squared. I kind of combine those steps right there. Divide by a negative 1, and I get 144 equals B squared. So B equals 12. So the distance from your center to one of your co-vertices is 12. So you double it to get the height of your eye, which is 24. And we're going to use our units, so 24 millimeters. All right? That's just how you can apply a real-world situation of an ellipse. Now the last little bit is we're going to be able to write each equation, which you guys should already be able to do, write each equation in standard form, but then identify the conic, okay? So you know already that a lot of these you're going to end up having to complete the square, so that's what I want you guys to do. I want you guys to complete the square for every single one of these, and then looking at what you have, I want you to determine which type of conic that it is. So go ahead and pause this video, complete the square. When you're ready to see the answer, press play. So hopefully you got this when you complete the square. Hopefully you recognize that you only have one square term, which basically meant that you had to move your y's and the 5 to the other side. And then hopefully before you even started completing the square, you already knew that it was a parabola. Because we've only dealt with one type of conic that only has one square term. Okay? But there is your standard form for your parabola. Here's the next one. Pause the video, complete the square, press play when you're ready to see the answer. Hopefully you got this. You recognize that both your x squared and your x and your y's were being squared, but both of them had a coefficient of 1, which meant that you could go ahead and move the 12 to the other side, complete the square separately with your x's and your y's, and then end up with, hey, this is a circle that has a center at 6, -5, and a radius of 7. You got one more to do. Complete the square. Probably I figure out which one this one's going to be. Still complete the square, and then I'll press play when you're ready to see the answer. Okay? Hopefully you recognize that both x's and y's are being squared. Oh! Excuse me. But there was a coefficient in front of your y's, which basically lets you know that this was going to be an ellipse. Hopefully you added the 7 over, completed the square with your x's, because since your y's didn't have a regular y, there was no need for you to complete the square there. But you complete the square with your x's, you added it to the 7 over. Okay. So when you added 7 and 9, you got 16. And then hopefully you realize again that this is definitely not a circle because your coefficients aren't the same. And so you divided everything by 16 so that you can have it equal to 1, because this was an ellipse. Okay? That had a horizontal major axis where a squared is equal to 6 and b squared is equal to 4. Here's the chart to basically help you in determining which conic it is. I've kind of already explained this in the last lesson, but basically whatever your x squared and your y squared are, those coefficients, if they're equal, if they're the same, it's going to be a circle. If you multiply them and you equal 0, then you know it's going to be parabola. In other words, you're not even going to have one of the squared terms because that's the only way you can get 0. And lastly, if you multiply them and it's a number that's bigger than 0, then you know it's an ellipse. We're going to be talking about hyperbolas, but basically when you multiply A and C, you're going to basically get a negative number. But when we talk about hyperbolas the next class, you'll understand, exactly why it's a hyperbola. So, hopefully you got these notes. If you have any questions, please make sure you let me know. And, yeah.